Okay, today I'm going to talk to you about halogens. So halogens are group 7 of the periodic table, so they're found towards the right hand side. This means because they're in group 7, it shows that they have 7 electrons in the outer shell. So the different halogens, so group 7 elements, are fluorine, chlorine, bromine, iodine and astatine. We need to know a few things about these different elements. So first of all, we need to know about the appearance of chlorine, bromine and iodine. So at room temperature, chlorine appears like a green gas. Whereas bromine, so if I show bromine just in a little test tube here, so bromine is a brown liquid. Now the nice easy way to remember that is Br starts for bromine and Br brown. Also, it should give off an orange vapour at room temperature as well. Now iodine here is a dark grey solid. So as you can see, as you go down group 7, down your halogens, the boiling and melting point increases because these ones are gases, bromine's a liquid, and these two are both solid. Now iodine also, when heated, gives off a purple vapour. So those are the appearances of each of those different halogens at room temperature. The next important thing to know about halogens is they are diatomic. Now what that means is they go around in pairs. So chlorine is Cl2. 2 chlorine atoms covalently bonded together to form a chlorine molecule. Bromine is Br2 and iodine is I2. Fluorine would be F2, astatine At2. So as you can see, they're diatomic, di meaning 2 atoms. So 2 atoms covalently bonded together. The next thing we need to know about halogens is their reactivity, because there's a trend as you go down the group. At the top of the group is the most reactive one in the form of fluorine. This is the opposite pattern to that of alkali metals. It's completely the reversed pattern. So this, for halogens, the least reactive, are right down at the bottom. What I'm going to do now is explain why fluorine is the most reactive and why it gets less reactive the further and further you go down the table. So I'm going to draw fluorine, which has 9 electrons. So there's the first shell. 1, 2, 3, 4, 5, 6, 7, 8, 9. So as we can see, because it's in group 7, I have 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell. So for halogens to get a full outer shell, they are looking to gain 1 electron. So they need 1 more electron to complete their outer shell. So when they're forming an ion, they need to attract electrons from another element, from another atom. So the reason why fluorine is the most reactive is due to the fact it has a very small atomic radius. The atomic radius is the distance from the centre of the atom to the outer electrons. So as you can see, fluorine's atomic radius is quite small. Now the reason why that makes it reactive is because of this. In the centre, in the nucleus, we have protons, which are positive, and they attract negative electrons from neighbouring atoms. So if I've got a very small atomic radius, there's going to be more attraction on these nearby electrons. Therefore, fluorine is quite reactive. So let's say we've managed to get that extra electron. So we now have a full outer shell. I'll just do it in a different colour to show it's come from a different atom. This is what we have. We have fluorine reacting or gaining an electron to form F-. So all halogens form 1- ions like this. So let's just have a quick look at chlorine in comparison. So chlorine has 17 electrons. So let me just draw this quickly. So what we should be able to see in a second is the fact that chlorine has a bigger atomic radius. The distance between the centre of the atom and the outer electrons is much bigger, which means if the positive protons are attracting neighbouring electrons, they're not going to be the same degree of attraction as with fluorine. So as you go down the group and the atomic radius gets bigger and bigger and bigger, there's less and less attraction on these neighbouring or these nearby electrons. Therefore, it becomes less and less reactive. So finally, just to show that, this time we have chlorine gaining an electron. So if it was to gain an electron, we would now have Cl1- ion. And that is the introduction to halogens. Thank you.